If you are a beginner in cloud or already working but would like to recap the basic concepts of cloud, then this program is or this free course is completely right for you. So let me first explain you what we are going to what you are going to expect in this full course. So we'll cover everything related to the cloud. Let me move myself here. So we'll begin with cloud basic concepts where we cover cloud characteristics, overview, and properties and benefits of cloud. And so we'll begin our journey with what the cloud is, the traditional architecture, what are the problems with the traditional architecture, what exactly the cloud computing means, and the characteristics or properties of the cloud, why cloud is becoming so famous, including some of the key concepts that should be knowing whether you are working on cloud or working in IT in general. You should already be familiar, or if not, we'll do a recap and we'll go deeper into what is high availability, disaster recovery, fault tolerance, scalability, elasticity, and the difference between elasticity and scalability you'll be knowing. Then we'll go to the next topic, which is CapEx versus OpEx, and you should be knowing why you're going on CapEx or why companies are looking for CapEx and the one big benefit of going to the cloud. And it's important if you are doing on a management level, sales, pre-sales guys, then this concept is important. And then we'll have some quiz to see whether you've learned, understood or not. Then we are going to look at the first, in my view, the first and most important concepts about in the cloud, which is cloud service model, which is infrastructure as a service, platform as a service, and software as a service. And we'll look at the pros and cons, which service falls under which category. And this is again, most of you guys who are here or watching this video probably would be going or working on infrastructure as a service and platform as a service. We'll cover with some examples from cloud providers like AWS, Azure, or Google and Oracle. What does PaaS, as IaaS, PaaS, and SaaS means? So these are some concepts from Google Cloud as well. And then again, we'll have the same quiz to see whether you've understood those concepts or not as well. Then we are going to go and learn the shared responsibility model. So when you're working with cloud, there are some responsibilities you as a customer should be doing or are responsible for, whereas some responsibilities are with respect to the cloud or with cloud provider. So based on whether it's an infrastructure service, platform as a service, or software as a service, these responsibilities differ. So we're going to cover that part later in this part. And then comes the second most important topic in my view is the cloud deployment model, which is a public cloud, private cloud, and a hybrid cloud. And we'll see some examples of private cloud from AWS cloud, Azure cloud, Google cloud, and Oracle cloud as well. What is private cloud means, and then how to implement a hybrid cloud. And then we'll finally wrap up the question with one of the most important question in my view, which you might be going through. Hey, I'm starting out in the cloud or I'm already working into the cloud. Which cloud is right now working or doing? Because things have changed a lot since 2008. I started my journey in 2011 on cloud. I've started basically in IT for since 2000, and then a lot has changed in especially in cloud world. So what's happening as well, and we'll give an opportunity on which cloud you should be picking based on your background and some of the pros and cons of each cloud. Not everyone is right for AWS versus not everyone is also right for maybe Oracle or Google Cloud as well. So which cloud you should be looking at, we'll do a quiz. And when you submit this form, which is k21academy.com/which cloud, will give you more useful content related to whether you want to go into AWS based on once you've understood which cloud you should be going on. Then based on that, we'll put you onto when you select the respective cloud, we'll send you more useful content related to that, whether it's AWS, Azure, Google, or Oracle, or there's a fifth option, which is multi-cloud, which I'm going to talk about a bit later. So we'll also look at towards and the comparison between these four cloud, which I'm doing between AWS, Azure, Google, Oracle. So that's pretty much we are going to look at in this full course that's available for you. And if you're wondering who am I, my name is Atul Kumar. I'm based out of UK and I have more than 2 decades of IT experience and more than a decade now in cloud and multi-cloud. What I'm biggest proud of is I've helped 12,000 plus individuals like you to learn cloud, multi-cloud, DevOps, and data engineering. And these are some of the happy customers that I've worked across the globe in my more than 2 decades working from all the way from UK to US to a lot of clients in as far as Middle East and Africa as well. But that's not how I started. I started my journey with merely earning less than £100 a day to then working very hard to move here in UK back in 2004, earning 2,400 pounds a month, to then earning 425 pounds a day, to then 500, 600, 7, 800, 900. Highest was 1,200 pounds in last 2022, 2021 as well. And if you would have asked me 20 years back, then I would have never imagined that this all this is possible. So my hope and my desire is that whatever I've learned to share with you and whatever I've achieved, just follow that and you can achieve that too as well. So so make sure that you pay special attention to this full course and towards and also see what cloud you want to do and learn. Learn like Yash, who've cleared 6 interviews, Yash or Kwame or Shubham or Winifred, Samarth, Tolu, not from being from a IT background. So a lot of guys come and say, "Hey, I'm not from an IT background, and I was never start with IT background." So if guys like these can do it in spite of Meghna with the no IT background, with career gap, or if you're struggling for interviews, all these things will help you in learning and achieving. So make sure you pay special attention, and towards end, make sure that you also see what cloud you want to focus on, and maybe you want to go for multi-cloud, but we'll see that. Now, for this program, I'm going to bring our expert, cloud expert. She's going to talk everything about cloud and the basics you will learn and give us a feedback in terms of what, if you have any questions, doubts, if it's not clear, leave them as a doubt as a question below this video, and they'll make sure that you get answer for that. If you need any help, also leave that as a comment section, and I'll see you towards the end of this video.
Okay, so first of all, I would like to congratulate all of you that you have taken this, step to enhance your career and introduce yourself to one of the booming technology, the world of IT more specifically, I must say, where people are still gazing around and are still getting confused, like when it comes to IT, what is the technology that one should learn. You guys have decided that you will be moving towards cloud, and I must tell you one thing, like in the upcoming world or upcoming days, the technologies that will be booming in IT will be, obviously, one is cloud computing. First and foremost is the cloud computing technology is going to boom, or you can say field or domain is going to excel in the market. Apart from cloud computing, there will be a domain of cyber security and data analytics that is going to boom. So there are only three domains in the world of IT which are going to boom, and out of them cloud computing is the one. So, this session we have prepared keeping in mind that you know nothing about cloud, and we will be explaining you about the cloud, what is basically cloud, what are the characteristics and the benefits of the cloud. We will make you understand about why you should opt for cloud, because you basically move to the OPEX model when you opt to the cloud thing. So we'll make you understand about CAPEX and OPEX concepts. And then we will also study about the types of clouds based on deployment model and based on service model. So we will be understanding about service models like infrastructure as a service, platform as a service, and software as a service. And we'll also understand about what is public cloud, private cloud, and hybrid cloud. We will have a very superficial comparison of various services being offered by various cloud providers in the market. Like currently, you must have heard about Amazon's AWS, Microsoft's Azure, and Google's GCP. These are the three cloud platforms which have actually captured the market overall. So, first of all, let us understand why cloud. Why do we basically need a cloud? So, traditionally, suppose say if you want to create your office, or you want to work and you want to introduce IT infrastructure in your domain or in your company, you were required to build the data centers on your own. The data centers are basically specialized rooms where your data is kept, distributed, and secured. As the name suggests, data center, a room which is a place where your data is kept in a central location. This data, which is available here in the data center, is distributed to various users, but it is distributed in such a way that it is secured. It is not open to all. There are certain methodologies which are applied so as to secure it. Because in the today's world, the most crucial, important, and expensive thing for a company is its data. And everyone is not leaving any stone unturned to make sure that their data is secure and is kept properly. So for that, the companies used to make data centers. Now when they used to make data centers, there were many challenges that were being faced. The first and the foremost challenge was because every company wants to establish themselves in tier 1 cities, and tier 1 cities have cost of living is very high in tier 1 cities as compared to other cities. 1 cities only. So every company wants to build their data center in the tier 1 cities. Now, when you are into tier 1 cities and you want to create a data center or build up a data center, obviously the rent required, or like suppose if you want to buy the place, then also the cost which is required for the place will be too high, very high. That initial investment that a company owner has to do, where like there will be a place where their employees will be sitting, but apart from that they also need to have a dedicated space where their data devices will be kept. There are certain devices which are there on which your data is stored and it is made available to the users. So where your data devices are kept and where your data is kept, that particular specialized room is known as data center. Now that data center that you are going to create, because there will be so many devices, like my one single laptop generates so much of heat when my laptop is running. Now over here in this data center there are servers which are actually kind of high end desktops. The desktops which are having higher capabilities is known as a server. So there 10 servers, 15 servers. I'm talking about a very small data center. Huh? Like if it is a big data center, then you will be having 100 servers, 200 servers, 500 servers, 1000 servers, like that. So in that particular room, there are so many computer devices running. Obviously, they will be you know dissipating heat, and you have to deploy solutions so that there is proper cooling maintained in the data center, because the servers, if they are kept in high temperature, they will start malfunctioning and they may even crash down. That's why in data centers the cooling has to be maintained. Now because these servers via which I am distributing, to make sure that these servers are always up and running. If the server goes down, the service is down. So I cannot take the risk. So the power supply that we give to the server, the internet connection that we give to the server, everything has to be perfect. In fact, I am required to have redundant services. That means if one power supply goes down, I should be having power from my second power supply. So for that, I will take power connection from my one electricity board and another power connection from the another electricity board. So if there is some issue in one power plant, I must be getting power from the another one. So, like that, redundancy is required to be maintained in the data centers. Redundancy in terms of everything, redundancy in terms of power, redundancy in terms of cooling, redundancy in terms of the hardware that is being used, redundancy in terms of internet connection that is being used. Everything was required to be kept redundant so that the service is not down. And when I'm saying that, if suppose say if one of my server is down, then my services will be running from my another server. So if this server is down, so obviously that server is required to be replaced. So that task is also taken care, is required to be taken care by you. So it was really very time consuming job and money intensive job to maintain a data center. Once you have built up a data center, you will also be requiring a team who can do the monitoring of the data center. Now, suppose say you have created everything in a very proper way. So, suppose say there is internet connections. So, you have taken internet connections from two ISPs, internet service provider. So, for the purpose of security, you have kept two firewalls in your data center. And then for every service which is running in your data center, you have got two servers. So this is your primary server, this is your secondary server. So for every service like this, you are having two servers available. And storage also, if you have stored something in the data center, you are even taking the backup of everything, so that if this storage crashes, then from the backup you can get your data. So you have invested so much of money, space, everything, and then you built up a data center. And one fine day, due to short circuit, there was fire and everything, god forbid, but then everything was burned out. Yeah, now you are nothing in hand. Or let not be the fire, there was earthquake in your area and the whole building in which you have created your data center got collapsed. So every redundancy, everything that you have created went into vain. It is wasted. And on top of it, your data is lost. Money is okay, but the companies cannot afford the data to be lost. So in that situations, what companies used to do is, okay, there is one data center created. So maybe 20-25 kilometers away, there will be one more data center that will be created. So if there is a fire over here, earthquake over here, tsunami over here, power shutdown over here, in whatever situation, you are having another data center from where your services are up and running. So it was actually now so much of cost, hard work, and efforts, intensive thing to maintain a traditional data centers. So what company owners were thinking, that why can't I outsource it? It is such a time consuming, money consuming, it is very difficult task to maintain a data centers. So what if I can outsource it, let somebody else do it for me? So there is a very common saying in the world that whenever there is a problem, there is a solution. And with every problem, one is going to earn. So this was the problem for the business owners, that in spite of investing so much, they were not having surety that their data is secure, because maybe they are not able to hire the right kind of people. And because suppose say if it is a person who is making cars, he is a mechanical engineer who has opened up his company, but IT is everywhere. So he has to maintain the data center, but he has zero knowledge about it. So for him, it is an alien technology, and it becomes very difficult for him to maintain that thing. So they wanted to get out of all this, and with this problem, the cloud service providers came into picture. They came out like genie. And they said, okay, well, if you have a problem, I have a solution for you. And I will offer you this particular data center as a service. So it is actually cloud computing is nothing but data center as a service. So the cloud service provider will give you data center, and that will be managed, maintained, created. Everything will be done by the cloud service provider. And what you will be doing is you will be basically using it as service, like you use the electricity. You are not going to go and produce the electricity now. What do? You get yourself a meter, you get yourself an electricity connection from the electricity board. From there, you distribute it in your home. This is how we do for electricity. The same thing the cloud computing service providers started offering you. They said that I will give you servers, storage, database, network tools, softwares. I will keep everything in my premise. Who? The cloud service provider. They will keep all these resources, servers, storage, database, networking, security related devices, storage, softwares, everything is kept in their premise. It is the cloud service provider who is going to manage everything. And you, as a user, will access these things over the internet. That means you don't need to maintain servers, you don't need to maintain storages, you don't need to maintain networkings. It will be everything done at Amazon's or Azure's or Google's data centers. If there is a hardware failure, it is the cloud service provider who will replace it. The cloud service provider will think about if there is a fire in this data center, what will happen. They will maintain the redundancy. You are freed up from this all burden, and you will be using data center as a service. That is what cloud computing is. The only dependency over here is it's a beautiful technology, makes your life easy and comfortable, makes, or you can say relieves the business owners from the burden of maintaining the IT infrastructure. The only one limitation that is there is internet connection. One should have a good internet connection so as to be able to use the cloud services. But nowadays, internet connection is not at all a problem for anyone. We know that we all are having like dual SIM mobiles. For what? For passing our time on Instagram, Facebook, WhatsApp. Someone are passing their time on Tinder, right? So we are having dual SIM mobiles. So that if one service provider, what we do is we are very smart. Like in India, there are service providers Airtel and Jio. So what we do, I'll keep one SIM of Jio and one SIM of Airtel, so that if in some area Jio's signal is not that good, then I will get good connectivity from Airtel. So I keep redundancy at the connectivity level. And for what? Just for playing videos and songs, right? So internet is redundant in everyone's pocket nowadays. So obviously the corporates must be enjoying a better internet than us, right? So internet is not a problem nowadays, and that is the reason cloud computing is booming, because with only that one limitation, otherwise cloud computing has so many benefits. First and the foremost benefit that you get from the cloud is on demand self service. No human is required to be interacted to get any resource. Suppose, say, if I want to create a server in cloud, now if I draw this as a server, it is my web server. So, suppose, say, I need a web server in cloud, I will just go click select, add to cart, and I'm done. Just like doing online shopping, I'm purchasing servers. Isn't it great? And those servers will not be delivered at my office. They will be there in the office of Amazon, in the data centers of Amazon, and I will be using it over the internet. And I can use it from anywhere. It has got such a broad network access ability. Whether I am at my home, this is our childhood home designs. This is how we all used to make homes when we were childrens. So whether I am at home or I am traveling in my car, or maybe I am at a vacation at a beach, or maybe obviously sometimes maybe I'm in office also. Wherever I am, I will be having internet connection. If I am connected to the internet, I'm connected to my infrastructure. So that is the beauty. Wherever you are connected. And another benefit that you get out of cloud is it enables you to do resource pooling. Now, what do you understand by pooling? Pooling means sharing. Am I right? We do car pooling when we are going to office. Why do we pool a car or a cab when we are going to office? Because if I and my neighbor are living in the same area and we both are working in the same office. So rather than me alone traveling by my car and my neighbor alone traveling by his car, what we can do is we will, have an understanding developed that in a week I will take 3 days, I will take my car, and for 3 days he will take his car. So we both are pulling the cars, and thus we are saving money. And in a way, we are even contributing to environment because lesser number of cars running, lesser amount of petrol or diesel consumed. And when there are lesser number of people on the road, obviously the roads will be empty. So I will be able to go fast to my place if we are doing pooling. So, although car pooling has got so many benefits, but the pooling of the resources in cloud has got the benefit of cost. When you are sharing something, then obviously you will be saving cost. Now, you must be thinking that if I am sharing, it is obviously not secure. How many of you thought about this? That if I'm sharing something, obviously it is not secure. How many of you have thought about this? Right? It comes to our mind that if it is being shared, that means it is not secure. But trust me, guys, when you are at cloud, you are more secure than when you are on premise because they have more knowledge and technologically they are more advanced as compared to us maintaining something at our premise. And in fact, few of the security features cloud offers for free also. So even though it is being pooled, there is a proper structure being maintained where we are having a complete responsibility model is defined. I'll show you something. See, security is defined in a very discrete manner in cloud. We will study about it in our class today itself. So, in spite your resources are being pooled, they are still secure. And you know what? Suppose say, like I'll give you an example. Suppose say I'm having a server, and whenever we go to buy a laptop, what do we see in our laptop? How many cores am I having? How much GB of RAM my laptop is having? What is the kind of processor my laptop is using? How much amount of storage am I getting? Whether it is an HDD storage or an SSD storage, all these things I do check when I am buying a laptop. When you are buying a server, the similar things are being checked. Even if you are buying a server, how much RAM is there, how many cores of processor is there, what kind of processor I'm getting with this server, how much storage, whether it is HDD or SSD, all these things we have to check for the server also. So suppose say at the time when you were buying the server, you decided to go for 8 core processor with 32 GB RAM and 1 terabyte of SSD storage, and you opted for i7 processor. Generally in servers, because you are well aware about this i3, i4, i7, so that's why I'm using that. But in servers we have processors of silver, gold, platinum type of processors are there. So suppose say like I'm having i7 processor, and after that, once you have procured the server, you realized that this 8 cores are very small for you. It's not getting sufficient on your requirement. What will you do now? The shopkeeper from where you have bought the server, he's not going to take it back. Suppose say you opted for 32 GB RAM. You are having 4 slots. In each slot you have installed 88 GB of RAM, and all your 4 slots are full. Now you realize, no, I need 64 GB of RAM. What will you do? You need to discard these 88 GB RAMs and purchase new one and deploy it in the traditional environment. But when you are in cloud, you have got the elasticity in hand. That means today you need 4 cores of processor with 8 GB of RAM. You applied for it, you got it. Tomorrow you realized that this 8 core is not getting sufficient for me. Okay, fine. You can enhance your server to 8 core with 16 GB RAM. You have used this server for 2 days, and from the third day you enhanced your server to 8 core. So you will be paying for 2 days for this server, and then from the third day onwards you will start paying rent for this server. Because in cloud, when you get a server in the cloud, you don't have to pay upfront amount. You will be paying rent, just like electricity. Similar to that, in electricity we pay bill. How much we consume, we pay for it, and it is very nominal charge that we pay, right? In cloud also, when you use a server in cloud, a storage in cloud, there will be a bill which will be generated. It is a measured service. You can see what is your ongoing bill, and according to that you will pay. So for 2 days you will pay for 4 cores and 8 GB RAM. From third day onwards you started for paying for 8 core 16 GB RAM. Then you realize, no, it is fine, it is okay with the 4 core and 8 GB. You can go back to 4 core and 8 GB RAM. You have this flexibility of moving from here to there in cloud, which you do not have it in traditional environment. So these are the various benefits that you get when you are working with cloud. So these are the benefits: reduced cost for infrastructure because you don't have to pay anything upfront. It is flexible, more secure as compared, scalable. That means whenever you want to grow in size, you can grow up. Whenever you want to come down, you can grow, you can shrink down. No location constraint. Now this is very beautiful and interesting. Huh? When I say no location constraint, you know what? I'm sitting in Indore, India. Indore is a very small city in India. tier 2 city, in fact. It is not even a tier 1 city. So it is a very small city in India, Indore, but a very beautiful and the cleanest city of India. It has been winning the award of cleanest city of India from 6 consecutive years. And now we are planning to achieve the award for the 7th year also. So very renowned city, although, but it is a very small city. But I don't have any constraint. If I want to go and create my server right now in cloud, I can do it. In fact, if I want to create my server in Paris, I don't have to buy a data center in Paris. I don't have to buy a server in Paris. I don't have to deliver it over there. Right now, today, within 5 minutes, I can log into my portal, go to the region, Paris, and I can deploy my server over there. In 5 minutes, I can do it. So, no location constraint. Isn't it interesting? Can you imagine that happening? Don't you think that this is very interesting? That is, no location constraints are there. So this is how a lot of benefits you are getting out of cloud. Okay. So see, basically, like cloud is having a feature of elasticity. Like an elastic, whenever I want, I can stretch it and grow in size. And whenever I don't want, I can leave it back and come back to the normal size. So this feature of scaling up and scaling down is available with me in cloud, which is not available in my on premise data centers. So that's why we consider cloud as more useful and easy to use technology. Now, in cloud, when we say that cloud, I people always used to say there is a very common saying, cloud is highly reliable and highly available service. Now, what do you mean by highly available service? Highly available service means high availability means what? Maintaining the acceptable continuous performance despite of temporary load fluctuations or failure in the service and the hardware in the data centers. Okay. So that is known as high availability. And high availability has to be in the terms of power, cooling, security, data availability. It has to be there. In terms, the availability should be for everything. My power should always be available. My cooling should always be available. My network should always be available. My data should always be available. My server should always be available. And to make it always be available, I have to make sure that I have redundancy being maintained. If one goes down, I can get my work done from another. So redundancy has to be maintained. So Amazon does it. It will give you high availability on everything. Okay. Whether it is power, cooling, network, data, server, security, at everywhere Amazon will give you, or the cloud service providers will give you the high availability. Disaster recovery means, as I said, that when there is a data center created by you which was having everything deployed perfectly, but if any disaster occurs like fire, flood, earthquake, political unrest, it could be anything, any disaster may happen. So if, like, remember, like in 2011 September 9/11, there was twin towers in US, and there were so big companies operational from these towers. They were commercial business hubs. People have kept their data centers into it, and one fine day it got crashed and it got disappeared. So that could also be a kind of disaster. You never know what can happen in this world. You are not sure about what is going to happen next. In the next moment, what is going to happen, you never know. So, so in case if you want to overcome such kind of disaster, that means if even if the disaster occur, your system should be able to recover. That is known as disaster recovery. Companies create disaster recovery plans. For that, they create disaster recovery sites. So there will be one primary location from where your operations are being done, and they will also have one disaster recovery site, that if this primary data center crashes due to any XYZ reason, all your data is available over here because you are doing replications in the background. So if this goes down, your data can be recovered from this location, and that is known as disaster recovery sites. To make sure that your business operations are up and running even in case of disaster, that is known as your disaster recovery plan or business continuity planning, BCP. In terms, we call it as BCP. Whenever you are deciding upon your disaster recovery plans, you have to think about the RTOs and the RPOs. Now, what do you mean by the RTOs and the RPOs? RTO stands for recovery time objective, and RPO stands for recovery point objective. Recovery time objective and recovery point objective. Now, what do you mean by that? Suppose say let's first. Okay, recovery time objective first. Okay, so suppose say disaster occurred at 5:45 p.m. All my services were down, but my DR site was here available. By using that DR site, how much time will I take to bring back my systems up and running? My operation will be back to normal. How much time will I require to achieve it? That is known as recovery time objective. The time required to bring the systems up and running after a failure is known as recovery time objective. Recovery point objective means when the disaster occurred and you are recovering your data. So the disaster has occurred at 5:45 p.m. The last backup that you done on the DR site was at 5 p.m., right? So because the replication has occurred at 5 p.m., that means 15 minutes. The data which was created during, sorry, not 15, 45 minutes. The data which was created at 5 p.m. was backed up on the DR side. But after that, the 45 minutes which has passed, the data which was created during that period of time will be lost. If you have deployed your disaster recovery planning in such a way, so you are having almost about like the next, according to you, the next backup was supposed to be at 6 p.m. So basically you are setting up a recovery point objective where the data loss will be for 1 hour, which is too high for companies. So generally they give you recovery point objective of 5 minutes, 10 minutes, 1 minute, like that. So you have to do the replication in such a manner that if your primary site goes down at 5:45 p.m., so your replication should be happening every 5 minutes if you have the 5-minute recovery point objective. So that is given to you by customer, don't worry about that. So accordingly you have to put money in your plannings. So this is how you decide upon your disaster recovery plans. If you don't want any downtime, if you don't need any downtime, if you don't actually need not, if you don't want any downtime to occur, then you know what you can do is very simple. You will create a load balancer environment. Your environment will be fault tolerant. So that means your system will be able to continue your operations properly, even if one or more component fails. It will not stop. It will not stop working. So what for that, you know what you will be doing is you will be basically running two or more backend servers. Like suppose say, I'll give you in a layman terms. Like suppose say your application was there. It was running on this server. You created a replica of this server and created one more. So there will be server 1 and server 2 which is running, and on both of them your application is there. Either you come to this server or you come to this server, your experience will be same, your data will be same. Then what you can do is you can deploy a load balancer in between, and this load balancer will do what? Whatever users are there trying to access the service, they will be basically landing on the load balancer, and load balancer will distribute the traffic between the two servers, maybe in round robin fashion. Round robin means, so user 1 will go to this, user 2 will go to this, user 3, user 4, like this one by one I will distribute the traffic. If in case there is a failure in my environment and one of my server went down, then what this load balancer will do, all the user requests which are coming from various users, all of them will be transferred to the single server only. So your operations will continue to work properly even if one of the component fails. So then it is known as fault tolerance. So you can have high availability or fault tolerance deployed in your environment. When I say high availability, it is like you are having one server, which is your primary server. All your users are coming onto this server. If this server crashes down, you are having the image of this server available with you. From that image, you will create a new server, and then the users will be forwarded to this. But by the time when the server was getting created and the traffic was being rerouted, you will be having a small amount of downtime. When the primary fails and the secondary takes over, it takes a little bit of downtime to get that failover happen. Okay, that is known as high availability. There will be a little bit of downtime which will be there. But if you don't want a downtime at all, then rather than you keeping the services as primary, secondary, you will keep them as fault tolerant. That means there will be one, two, three running behind a load balancer. The traffic is being distributed in all the three. If one crashes down, you will be still being served by two. If another also crashes down, you will be still being served by one. Your service will be down if and only if this third one also goes down. So I have configured the fault tolerance level up to three machines. So it is your company's choice how much fault tolerance do you want to deploy in your company. So this is your fault tolerance and high availability. In high availability, if one goes down, another will take over, but it will take some time. In fault tolerance, there were already two, three, four available. If one goes down, doesn't matter, rest of the three are serving you. If two goes down, two server goes down, other two are serving you. It's like, like suppose say you went to a theater to watch a movie. There was only one ticket counter from which you can buy the tickets. There was a line of 200 people to buy the ticket. And all of sudden this man got nature's call and he went out. The counter is empty. Your operations are stopped. So to make sure that this doesn't happen, company has done what? They have kept one resource which is doing other job actually, but he knows how to do the ticketing. So what he will do, he will call this fellow and say, boss, I'm going out for 20 minutes. You do one thing, you come here and start doing my job. So this guy, he will go away. This guy will come and he will sit on the counter and he will start issuing the tickets. If I was having three ticket counters instead of one, there were ticket people sitting over here. So I was having 50 people here, 50 people here, 50 people here, all of them being served at a time. If this person is not feeling well and he shuts down his system and goes out, so then these people will come in this line, but they will be served. It's not so that the services are stopped, the services are still up and running. When you are doing the things online, you are actually not in the line. It will be thousands of people accessing the web portal of booking the ticket. So if one of the server goes down, the users will be served from another server if it is highly available. And if it is fault tolerant, there will be already 2 3 servers and the users were getting distributed over here. If one of the machine goes down, never mind, the 1,000 users will be distributed on these two machines. That is what the fault tolerance is. No downtime. What you asked for. So then you have to make the system fault tolerant. Obviously it will be more expensive as compared to high availability. Okay. Elasticity. So now you have got two things: elasticity and scalability. There are two things: elasticity and scalability. Ability to increase or decrease the count or size of the existing resource based on the traffic fluctuations or load. Okay, that is known as scalability. Based on the load fluctuation, if you want the infrastructure to be scaled up, then you will be needing scalability feature. If based on the traffic fluctuation, like suppose say, let me give you an example. I was having a load balancer behind which three servers were deployed, which was serving my clients. Let's suppose say, let me give you an example. I am a flower selling website. I was having three servers deployed for my infrastructure. All my users from the internet used to open the web portal of my application. They used to come to the load balancer and their traffic was distributed between these three servers. So on normal days, my these three servers were able to entertain the load of my users. But during the Valentine's week, obviously, more people are ordering bouquets, flowers, gifts for their loved ones. So the load on my server started increasing. And my these three servers which I have deployed were completely consumed. The resources were completely consumed. and due to which my systems were not able to perform well. So my these users were becoming unhappy with the services. Why were they becoming unhappy with the services? Because my system was going really very slow. They were very unhappy. So what they do? They went to another website to order the flower. So it's my business loss. I cannot afford this happen. So what will I do is there are two ways to keep my customer happy. I can scale my system horizontally or I can scale my system vertically. What does that mean? Like I can, I know when there is a Valentine's week, at that time, what will I do is I will deploy, like there were three servers, I added two more servers behind the load balancer. When the load was high, I added two more servers behind the load balancer so that during the Valentine's week, my system was able to tackle the load. So I have scaled out my infrastructure horizontally. I was having three, I created two more, and I have scaled out my infrastructure. This is one way, which is known as horizontal scaling, where I have additionally added more resources, or you can say where I have added more instances behind my load balancer so as to support the increased load. This is one way of scaling, and it is known as horizontal scaling. Otherwise, I can do one more thing, that instead of adding more servers, I can actually, enhance my current servers only. Earlier, they were of 4 core processor, 8 GB RAM. I enhanced it to 8 core processor, 16 GB RAM. I have increased the size of my current running servers. Rather than servers, I have added the resources to the current server itself. So it is known as horizontal scaling. I added the resources to the current servers only. So it is known as vertical scaling. Like I have scaled my server from one core to four core server. The same server, I added some more cores to it. I have scaled it up vertically. So this is known as vertical scaling. So when the load is increasing, I can do horizontal or vertical scaling to support the increased load. That is known as scalability. For my infrastructure, which I have deployed, I can do that. It is known as scalability of my solution. Elasticity means, suppose, say, it is actually a capability of a service. Elasticity is a capability of a service. Whether this service allows you to grow up or scale down. Whether a service is allowing you to grow in size or to shrink in size. Like I will give you an example that will make you understand it more. I have got virtual machine in cloud. We call it as EC2 instance in Amazon. So suppose say I have got a EC2 instance in cloud. I If the load increase, I am adding more servers to my infrastructure. That means I am scaling my infrastructure horizontally. If I add resources to the same server, I am actually doing the scaling in vertical fashion, but this is known as scaling. Now just think about storage. I say that one of my service in Amazon, like EFS, Elastic File System. We call it as it is elastic by nature. Why do we call it as elastic? Because whenever I want like to be stored, I will get allocated 2 GB in AWS or in Azure or in GCP. As soon as I added 2 more GBs of data, this storage will get expanded and now it can accommodate 4 GB of data. So it was able to grow in size like elastic. As you keep on getting, if as you keep on adding data, it was expanding its size of storage and you are charged for that only. So you can increase the size of the storage based on the requirement of the data that you are required to keep in this. When you remove the data out of it, the storage will shrink down. So that's why we call it as elastic file system. So my ability to increase in size or decrease in size whenever required, this ability of a service makes the service elastic. Okay. Now this elastic, it is everywhere in Amazon. Like if I take you to the live portal AWS console, I'm taking you through the live portal of Amazon. This is one of the cloud service provider in this world. Although you must not be having a account in AWS, but I want to show you something. You can create a free account in AWS and can use Amazon for free. There are certain services up to certain extent Amazon offers you for free. So I'm logging into my portal. I'm providing my username and password. And because I have enabled dual factor authentication to keep my account secure. Now you see over here, if I want to launch a server in AWS, I will actually go to EC2. It is also Elastic Compute Cloud. It is virtual server in cloud. So you can have machines over here. Like suppose say, don't pay attention to what I am doing to launch an instance. Okay. Just pay attention to one thing that I will show you specifically. So this is my test machine that I am creating for you guys. Don't pay attention to any of these things. Reason behind you'll get confused. See, I'm launching the machine. This is a virtual machine got created in the cloud without any efforts. In few clicks only I got it created. Cloud is very easy. Now you must notice that this is a T2 micro machine. The instance type is T2 micro. If I write T2 micro in the search bar, you will be able to see that T2 micro machine means 1 core of CPU and 1 GB of RAM. This small machine it is T2 micro. Now in Amazon, if you stop the machine, if you want to grow this machine or you want to add more capabilities to the machine, you can stop it and can change the machine from T2 micro to T2 large, which will have 2 cores of processor and 8 GB of RAM, or maybe T2 extra large with 8 core of processor and 32 GB RAM. And the process is so simple that you just need to stop the machine, click on and change the instance type. That's it. Choose whatever you want. Like suppose say I want T2 2 extra large. Apply. So see now my machine is 2 T2 2x large. Now T2 2x large means 8 cores of processor, 32 GB of RAM. If I start the machine, it will be started with this size. If I want to shrink it back again select the machine, instance setting, instance type, change it to T2 small, T2 micro, whatever you want. I chose T2 micro again and apply. My machine is back to T2 micro. So it is the elasticity that I am getting on my EC2 instance. Whenever I want, I can increase the size of it. Whenever I want, I can decrease the size of my this service. So my EC2 service is elastic. But if I want this elasticity to be utilized in my workload, then we call it as scalability. Ability of my workload to grow in size whenever required, whether growing in size horizontally or vertically so as to support my operation, is the ability of my workload that I create in the cloud. So, elasticity is on the service level and scalability is on the deployment level. Okay, elasticity and scalability. I know it is little confusing. The instances are spun up or brought down depending upon the need of the client. Yes, that is why we call it as on demand. When we say cloud is on demand, that is the actual meaning of it, that they are on demand service. Whenever you want, you can spin it up. Whenever you want, you can stop it. Whenever you want, you can terminate it. You don't want it now. You destroyed the machine altogether. So that is what your cloud is, on demand. That is the beauty of the cloud. Cloud is elastic and scalable. Scalability is a strategic operation, whereas elasticity is a feature of a service offered to you by cloud. Scalability is for the workload deployment that you are creating. Elasticity is the feature of your workload. Now, capex and opex. Capital expenditure, operating expenditure. Suppose say if I buy a house of 1 crore Indian rupees INR, that means I am doing capital investment of 1 crore rupees. What is an operating expenditure? Once I have purchased a house, obviously I will need a maid to keep it clean. So that is my operating expenditure. If I talk in terms of IT, suppose say you needed 4 servers, you have purchased 4 servers, maybe of 40 lakh rupees, 40 million. In international number system, if I talk, it is suppose say in 40 million, you have purchased 4 servers. 40 million is too high. Let's make it 4 million. So I have purchased 4 servers in 4 million. Then this is known as my capital expenditure. Once the servers are purchased, I will need to give them power. Every month there will be a power bill for the server that I have kept. So my monthly expenditure will be on power, internet, resources, who are managing this server, So this is my monthly bill that I need to pay. So that is my operating expenditure, OPEX. To operate my server, I need these expenditures to be done. The one time investment you have done to buy the server, not in cloud, I'm not talking about cloud, I'm talking about on premise, traditional data centers. So, suppose say you have purchased four servers, that is your capital investment. To keep those servers up and running, you need power, you need internet, you need resources. That is your monthly operating expenditure. That is known as OPEX. CAPEX, OPEX. It is upfront, and OPEX is pay as you go. You have an employee, you will not pay him salary for an year or 2 year, or you will not purchase him for the lifetime. He worked for you for a month, you will pay him a month salary. He worked for another month, you paid him another month salary. Electricity, you do not pay electricity, huge hefty amounts to electricity board to deploy their infrastructure. You got a bill of 4,000 rupees, you paid that much for that month. Next month you got a bill of 7,000 rupees, you paid 7,000 rupees. Another month you got a bill of 3,500 rupees, you paid that. So whatever amount of electricity you are using, you are paying bill for it. So pay as you go. That is your operating expenditure. Capex and Opex. Companies always prefer to keep the things in OPEX model. You know why? We will earn, and from our earning, I will pay. It's easy for them to do it. But capital investment is very difficult for a company, because this is the amount that they have to invest even before they have earned anything. Upfront, they need to invest. So companies don't like that. Suppose say if there is a bus operator, he wants to start a service, bus service from a place to another. So he has to first buy the bus. That will be his capital expenditure, buying the bus. Then petrol or diesel, driver salary, wear and tear of the bus, toll expenses, they are pay as you go model. So they will be like buses running, they it is carrying people, they are paying uh, ticket charges. Out of that, I am using it for petrol, I am giving salary of my driver, I am giving my toll. It is fine because I'm earning, I am giving, my profit is in my pocket. Operating expenditures are always preferable by the companies rather than capital expenditures. So what cloud does is they have made your IT, or you can say your compute. Whenever earlier, when the cloud was not there, na, at that time your compute was your capex. You have to buy the storages, you have to buy the networks devices, you were required to buy the security devices. Everything was required to be purchased upfront, and the money has to be given to the vendor upfront. So that was a capital expenditure earlier. Cloud has made it. Cloud has converted your compute from capex to opex. So now you are not required to buy the server today. You are not required to buy or spend millions of rupees to buy server, storage, network, security devices. You will pay monthly rent of those devices. So you are doing your operations in cloud. Out of those operations, you are earning money, and from that money, you will pay monthly bill of your resources, and rest you will keep it in your pocket as your profit. So it becomes easy for you. So cloud has converted IT from capex to opex. That is the biggest benefit what cloud has brought. Let's try to answer this question. What does compute instance vertical scaling means? What vertical scaling out of these four, what is the answer according to you? Oops, I helped you to do cheating. I'm sorry. But by the time you guys have tried to answer it, so you were giving C as answer. So C has what? Adding additional compute instances. And the fourth answer is changing to a larger or smaller shape. So actually, I don't know. I'm really sorry, guys, but it should be changing to a larger or smaller size of the same resource, not shape. So answer is D. Answer is D, but the shape word is not correct. It should be size. Yes, correct. So now we will understand about the cloud more in depth. Like now we have understood what cloud is, what are its benefit. Now let us understand about what cloud is. What are the different types of cloud? What is cloud has been done. So basically, whenever we are buying services from Amazon, what all you can buy? You can buy a virtual machine, you can buy storage, you can buy load balancer, you can buy networking component, security, like these certain things which are there which you can buy. You can buy databases, HPC. These are the things which you can basically buy from Amazon. Actually, this diagram may little confuse you, so I'll tell you in a layman language. Now, this one is a very right diagram which can explain you what are the different types of service models are. Now, see over here in the traditional data center environments, when we were not having cloud, there were servers which are connected to the network. There was storage associated with the servers. There were operating systems which are loaded on the server. The applications were loaded on the server. The data which was required by the application was loaded. There were runtimes and middleware softwares which are loaded on the server. And if you are using virtualization, then that was also loaded on the server. So basically, virtualization is what? Ability to split a single physical server into multiple virtual machines, where all of these will behave as individual machines. They will behave as individual machines, but physically they were sitting on a single physical server. This is known as virtualization. So, when I say creating a virtual machine, it is actually a virtually, it is an independent machine, but physically, there are multiple VMs on this physical server. So to deploy this technology, I need to do or install hypervisor which enables virtualization on my servers. So earlier we used to do all these things by ourselves. The client used to manage the network, the storage, the server, the virtualization, OS, middleware, runtime data, application, everything was required to be managed by by the client. Then the cloud service providers came into picture. They said, I will give you three models. One in which I will handle the server, storage, network, and virtualization. The client will manage their application, data, runtime, middleware, and OS. So some part will be managed by the cloud service provider, and rest will be managed by the client. So basically, infrastructure will be given by the cloud service provider, network, storage, server, virtualization. So cloud service provider will create the VM for you, do the operating system installation for once, then patching the operating system, installing runtimes and middlewares, loading the data, installing application, managing the patches on it, keeping the data backups. Everything is the responsibility of the client. So all that has been marked in dark blue will be managed by client, and the things which are marked in light blue will be managed by the cloud service provider. Then it is known as infrastructure as a service. But if you want to leverage some more tasks to the cloud service provider, that means you say that operating system, middleware, and runtime will be required to be managed by the cloud service provider. The client will manage only their application and the data related to the application. Rest everything has to be taken care by the cloud service provider. Then we call it as platform as a service. And if you want that everything is required to be managed by the CSP only, cloud service provider, client will not do anything. Client will only create an account on the application and they will start using it. They will not manage anything out of these. Everything has to be managed by the service provider only. Then it is known as software as a service. So, in the short form, they are also known as PaaS, PaaS, SaaS. Infrastructure as a service, platform as a service, and software as a service. These are the three service models which are available in the market. So, when I talk about AWS, the infrastructure as a service offering is the virtual machine that we created just a few minutes or like sometime before. I have created a virtual machine in cloud now, that the EC2 service is basically your infrastructure as a service, because in that you will get RAM, CPU, SSD, storage. The server will be connected to the network so that you are able to access it. These things will be managed by AWS. It will even do the one time operating system installation. But then, after patching the operating system, installing the application, loading the data of the application, patching the application, installing the dependent softwares of the application, everything has to be done by the client. So that is known as infrastructure as a service. Platform as a service, Amazon's offering Elastic Bean Stack and relational database service. They are actually PaaS services of Amazon. So relational database service is actually a database offered to you by Amazon, in which you will just tell once that whether you want to use MySQL or PostGRE or whatever you say. You will say it once that I want to use, suppose, say MySQL. So Amazon will do the operating system installation, MySQL installation once, your softwares which are required in the background to run the MySQL will be loaded and maintained by Amazon. You will only bring the MySQL which has been installed by AWS or by Amazon or by Azure. So then it is known as platform as a service, where the whole platform has been created. You just load your application and the data. Like suppose say you are a developer. You said that I have created my code in Node.js. My application has been created in Node.js. So Amazon's platform as a service will create a whole platform on top of which a Node.js application can run. You will install your application and the data relevant to it, and you will start working. So that is a PaaS offering by Amazon. And the last is the SaaS offering. These services that the people have shared on the screen are SaaS offerings, software as a service. Like when I use Instagram, do I ever worry about who is creating this application, where the data and the reels which I upload are being stored? What is the platform that is being used? This application is hosted on which operating system? Where is the storage associated is? How is the network configured? I don't bother about all these things. I just create my account in Instagram and I'll start using it. Everything else will be managed by the cloud service provider. Then it is known as SaaS, software as a service. All these services are basically your SaaS offerings, software as a service. Okay, very rightly said. Like in for AWS, I said that infrastructure as a service offering is EC2 instance. For Azure, infrastructure as a service is basically your VMs that you create in Azure. For Google, your compute engine that you create in the cloud, that is your infrastructure as a service. So all the clouds basically offers you this as PaaS SaaS. So in Google, for PaaS, it is Google Kubernetes engine or Google App Engine, which is there. In SaaS, Google has got its Gmail, and G Suite is also there, which is offered by Google. Office 365 is Azure's offering, AWS offering. G Suite is the offering of Google. So like this, if you talk about Oracle, Oracle also give you infrastructure as a service, platform as a service, and software as a service. Google gives you compute, storage, and load balancers. Sorry, Oracle gives you this thing as infrastructure as a service. For platform as a service offering, Oracle has got database cloud, content and experience cloud, and Java cloud. And for SaaS, it has got applications for sales, HR, ERP, which are hosted in cloud, where clients create their account and start using these services. So all of the cloud service providers are offering you this thing: infrastructure as a service, platform as a service, and software as a service offerings. Now tell me the answer for this question. Which resource do you manage in a infrastructure as a service offering? Whether it is networking, server, storage, or OS. When you are purchasing infrastructure as a service from Amazon or AWS or Google, out of these four, which is the resource that a client is required to manage? The answer is operating system. The server hardware is managed by the cloud service provider. It is you who will be worrying about the patching of the operating system and all. Is the right answer. The D. D is the right answer. Okay. Let's move ahead. The shared responsibility. So, when you talk about the security, because It's two people playing or contributing to the resources which we create in the cloud. Okay. So the responsibility is also shared between those two people only for the security. It is the client and the AWS or the cloud service provider. So it is the customer or the AWS or the cloud service providers who has the responsibility. Now, sometimes the responsibility is purely handled by the cloud service provider for some cases. For some cases, it is purely the responsibility of the customer, and at some places, it is being shared by both of them. Like, suppose, say, the physical security of the data center, of the network, of the hosts is basically with the cloud service provider. If you are using SaaS, the physical security will be required to be taken care by the cloud service provider, whether we are in as PaaS or SaaS model. The physical security of the host, network, and the data center, it is the cloud service provider who will take care of it. But if you are in on-premise environment, obviously it will be your responsibility only. Securing your operating system is the responsibility of the cloud service provider if I am using SaaS or PaaS. But if I am using infrastructure as a service, where operating system is the responsibility of the client, then patching it, securing it is also the responsibility of the client only. Network controls. It is completely owned by AWS or the cloud service provider for SaaS models. For PaaS and infrastructure as a service model, for PaaS it is shared. Means Amazon will create the security policy or the cloud service provider will create the policy, but it is you who will having an authority to allow or to disallow people. So if you allow everyone, so in spite Amazon has given you security, but because you have opened the doors, so Amazon and you both have to be taking care of that part. Network control, application security, that has to be taken care by you and Amazon both if you are in the PaaS model. But if you are in infrastructure as a service model, then all this operating security, application security, everything has to be taken care by you only. This is the shared responsibility model. Now, the security of the information and the data, it is always in the kitty of the client. Always, whether it is SaaS, PaaS, or infrastructure as a service. It is always the responsibility of the client, the data and the information. It has to be taken care by the client only. So, this is how Amazon has defined the roles and the responsibilities of who will be doing what. Now, suppose, say, let's try to answer this question. Which of the following is the responsibility of customer? So, the answer is security of the data hosted on the Azure virtual machine. That is the answer. Because I have told you that the data security is always the responsibility of the client, not anybody's else. Now, as I have told you that the cloud can be classified based on the service model in three categories: infrastructure as a service, platform as a service, and software as a service. And I have also told you about that cloud is all about pooling the resources, right? That means I am sharing the resource, the cloud. Now, there are actually three types of clouds that you can deploy. The public cloud, which is actually being shared by everyone. You can even create a private cloud, which will be owned, or you can more specifically say, which will be used by a single customer. So there are possibilities where you can actually ask the cloud service provider to create a data center for you exclusively. It will be only your employees who will be able to enter into this data center. Although this data center is created by the cloud service provider, it is being managed by them only, but still anybody and everybody cannot come to it and create their resources inside it. It is only for a single user. The data center has been created by the cloud service provider. Then you call it as private cloud. But if anybody and everybody can come inside and create the infrastructure in a data center of the cloud service provider, then it is known as public cloud. And if you want, like, because every company has two types of data, one which is very critical to them and they want to keep it really very secure, so they can keep that highly private cloud, whereas recreatable and non critical data can be kept in the public cloud. So the same company has kept some of the infrastructure in public cloud and some of the infrastructure in private cloud, and they have created a bridge between both of them. So whenever the user is there in the public cloud and he wants to access some critical information, then he will be required to get authenticated by providing the authentication, and then only he can go and access the content which is present in the critical area, that is the private cloud. So if we do this kind of hybrid deployment where some of the infrastructure is in public cloud and some of the infrastructure is in private cloud, then that type of cloud deployment is known as hybrid cloud deployment. Public, private, and hybrid. If the whole data center is for a single customer, then it is private cloud. If it is being shared by multiple customer, it is public cloud. If your company has created an infrastructure in such a way that some of the infrastructure is in the public cloud, some of the infrastructure is in the private cloud, and there is a bridge created between both the clouds, then you call it as hybrid one. Okay. Now next comes the outpost. Okay. So outpost is basically a private cloud only. Huh? But the only difference between a outpost and a private cloud is the private cloud is created in the premise of the cloud service provider. The private cloud, the data center will be created in the premise of the cloud service provider. So if you are creating a private cloud, it will be used by a single customer, and the location of the data center will be the premise of the cloud service provider. But if you want to create a private cloud for the single customer, but that will be in your premise, you will give Amazon a room where Amazon will come and create a data center for you. It will be managed by Amazon, maintained by Amazon, privately created by you, but it will be in your own premise. Then it is known as outpost. Clear? It is like private data center only, but created in your premise. The private clouds are usually created in the premise of Amazon, and Outpost is a private cloud created in your premise. So you need to invite Amazon saying that I have a space, you come and create a data center in my premise. So by using Outpost, you can create hybrid environment. So you invited Amazon to create an outpost in your location, and some of the infrastructure you have launched in the public cloud of AWS or Azure. So your on premise outpost is your private cloud, and some of the infrastructure is in public, and you have created a tunnel between them. So then it is known as hybrid cloud kind of thing. In Azure also you can do the same thing. Over there it is Azure Stack Hub, which is an extension of Azure. Okay, that provides a way to run your applications in on-premise environment. In AWS, Azure gives you Cloud Stack Hub. So Cloud Stack Hub is created in the on-premise, which is connected to the public cloud. So you can run your applications locally in your own premises by using Azure Stack Hub. In Google also you can create the hybrid cloud. So you can have containerized infrastructure created in your on-premise, and you can do the logging and monitoring in the cloud for your application. So like that you can create a hybrid environment in Google. So basically AWS and Azure gives you a better hybrid environment. Let's try to answer this question. A customer needs a data center for its application that are connected to AWS using the direct or dedicated network. So if I draw it diagrammatically, there is a data center of customer, and its applications are available here. Okay. And they are connected to AWS cloud using a direct connect link. This is a public cloud. So now tell me whether it is a public cloud, multi cloud, private cloud, or hybrid cloud. So answer is hybrid cloud, because see it's very simple. It was on-premise data center of customer, which is actually private to the customer, communicating with the AWS cloud, which I said is public. So when public is communicating with private via any method, whether it is over internet or it is via direct connect, public and private, that means it is hybrid. Okay. Next question. You are trying to understand the different cloud models. Which of the following are advantages of using public cloud? Give two answers. Choose two. So answer is A and C. Lower capital cost and high reliability. These are the two benefits.
Hey, so that was our cloud expert. She's talking about the cloud basics, concepts, including characteristics, properties, cloud service model, deployment model, and last section we saw public, private, and hybrid cloud. So make sure that if you're not clear, any questions you have, you're posting them onto the comment section. And if you're enjoying the session so far, do share with your friends and colleagues because that's how we learn and we learn in a group. Now, in this section, I'm going to take it from where she left, which is about the cloud, four cloud providers and which cloud out of these you're going to talk. I'm going to also, or should be picking and learning. I'll also be talking about Gartner's Magic Quadrant that talks about what are the top four contenders as of early 2024. I'm talking about here, and which one you should be doing. Also, as I said at the start, make sure you go and go to k21academy.com/which cloud after watching this and suggest which cloud is right for you. And for you, I've also given an additional fifth cloud, which you may not aware, or which changed my life, as I said at the start in 2019, where I went into very high trajectory, and I would suggest you to have a look at that cloud, fifth cloud, which is surprise, which is going to see at the end here. Which is, you can check it out by going to k1academy.com/which cloud. So have a look and let me know. And let's look at the four clouds and or maybe and the fifth cloud, which I did back in 2020 that changed whole thing. So let's look at now which cloud and Gartner's Magic Quadrant as well here. So if you look at Gartner's Magic Quadrant, this is as of October 2023, which is also I think it's January 2024 around that time frame. So towards end of 2023, early 2024, Gartner's Magic Quadrant for strategic cloud service platform. These are the four cloud providers, which is Amazon AWS. In terms of if you're familiar with Gartner's Magic Quadrant, and if you're not, they create this is the vertical line is ability to execute by a particular vendor, and then completeness of vision, which is on horizontal line. So if you look at here, AWS, Microsoft, Azure, Google, and Oracle, these four stand for from a strategic cloud platform services as well. So the common question I get is a should I learn AWS? Should I learn Azure? Should I learn Google? Or should I learn Oracle? That's a common question I get, and that's what I was trying to answer. And I'll give all the four and which one should I pick, and I'll tell you my story as well, which one I picked, and what I would do if I have to do it again, or someone, or what I'm doing right now. I'll cover that as well. So first and the most important is from a market share point of view, from an infrastructure as a service, platform as a service, the number one is still Amazon AWS. They are again by Gartner um, from a infrastructure as a service and a platform as a service on a 13th year on 2023. They've been named as leader in that. So AWS is still a big market share on AWS, but and then followed by Microsoft Azure Cloud. And Azure Cloud is, in my view, fastest growing as well from a growth point of view. And what Gartner suggests is a visionary, both in terms of platform services or infrastructure service and platform services as well, but also AI and machine learning, or mainly for AI developer related services, AI as well. So if you're moving towards AI work, we'll talk about that as well. But this is just to give you a glimpse of. Now, more than 95% of Fortune 500 companies use Microsoft Azure Cloud. So this is just to give you that AWS and Microsoft Azure are neck on neck, very, and I think my gut feeling says that Microsoft Azure over the next 4 or 5 years will surpass AWS. But I may be wrong on here. But the main question is which cloud you should be picking based on your background. So these are the four options we have: AWS, Azure, Google, and Oracle. So based on that, let's suppose you're a complete beginner to IT, or if you're a developer, or working on infrastructure, or data engineer, AI, machine learning enthusiast, pretty much all of them. Uh, Mainly if you're a complete beginner or beginner to IT as well, then I think AWS. Or if you don't have any preferences with respect to Azure or Google or Oracle, and you're not working any of those technologies, and you are work independent of that, I think, and if you only have an option to pick one, then Amazon. Now, why choose? I've already mentioned it's a market leader. There are a lot of job opportunities if you go to the job portal. Also, they have pretty much all the services, quite mature services, and they were the first one who started cloud, the whole term cloud coin AWS, and they're very, very. I think the most in-depth, I think Microsoft Azure also pretty much same, but very in-depth documentation as well as good community support as well. So AWS, I'll hold and I'll give you the my whole full picture as well. So that's Microsoft, that's Amazon AWS. Now, Microsoft Azure Cloud, if you're already working on Microsoft technologies, maybe you're working on Microsoft, for example, on-premise Active Directory, or you're working any of the Microsoft products, you use .NET or you use um, more on a C Sharp and C and .NET, and more on a programming application point of view, developer point of view, uh, then probably Microsoft Azure. So if you have inclination, if you're already using Microsoft products, then Azure might be. Also, why pick Microsoft Azure Cloud is I've seen a lot of security related things like Azure Active Directory, which is now Entra ID, Defender, a lot of security products, a single sign-on, federation, and so on. Those are Microsoft's quite strength. Now, Microsoft, as you see, ChatGPT, OpenAI is owned by Microsoft, so they have a Microsoft product around that side as well. They also have Office 365, quite heavily used, and they've dynamic. I think Microsoft Dynamics, which is their ERP CRM suite, and then also they're pretty good in Microsoft SQL Server. So if a customer is already using Microsoft SQL Server, then then I think Microsoft Azure. They're also fastest growing as well as they're quite heavy in AI and machine learning as well. Um, and if you have a customer who is already implementing or already have Microsoft products, then it's probably Microsoft Azure. Again, we'll talk about that a little bit later. Google Cloud. Google Cloud is pretty very strong on especially machine learning and data and very heavy duty or heavy, more advanced big data kind of a applications. BigQuery, they have a BigQuery and TensorFlow. Also, they're pretty strong in Kubernetes, which was, if you see containers and Kubernetes, Kubernetes was donated by Google team. They have a Google Kubernetes engine, which is Google Kubernetes implementation in Google Cloud, Google Kubernetes engine. So if you have containers and Kubernetes, especially Google Kubernetes engine, if you have a client who's using heavy on data, they're using BigQuery and so on. Then I think machine learning focused, very more advanced data specific, data intensive than Google Cloud as well. So if you're doing AI machine learning researchers, practitioner, pretty good in Google Cloud. And then finally, Oracle Cloud, which is if you're working on Oracle databases, pretty niche, or if you're using Oracle e-business suite, ERP, databases, PeopleSoft, JD Edwards, Siebel, all the old Oracle systems, as well as Exadata Cloud, so Exadatas, which is engineered databases, data appliances, database appliances, and so on. So if you're already working on, or if you have a client who's using Oracle software as a service, which is a fusion application, they have ERP cloud, CRM cloud, and so on. Something similar to uh, PeopleSoft, no, something similar to Salesforce and those kind of a things. You have so that SaaS, if they are implementing those SaaS applications, they will need infrastructure service and they will need platform as a service. So that's when Oracle Cloud comes handy. Now, from an infrastructure point of view, infrastructure and platform as a service point of view, Oracle Cloud is not as huge as AWS or Azure, but they're pretty niche. And if you're working on Oracle databases, then probably it's a good choice. So depending on if you are working on Oracle databases, Oracle ERP, e-business suite, then you have an option of Oracle Cloud. If you're working on Microsoft products already, or if you see a lot of jobs in Microsoft Azure Cloud, then you pick Azure Cloud. If you are working on data or you're implementing some projects, if you have a client who's implementing project in Google, pick Google. And if you're completely new to IT or just want to move into cloud, I think AWS and Azure is a good option for you. I started back in 2012-13 when I was transitioning to from an on-premise to I picked up first Oracle Cloud because I was already working on Oracle and I had a couple of clients who wanted to move from an on-premise in here in UK to cloud. So that's when I picked up Oracle. But then soon I realized that hey, in order for me to become multi-cloud or to become best in what I'm doing, I need to learn multi-cloud, and that's what I'm going to cover in the next part of this video, which is multi-cloud. So we'll talk about that later as well. So what I want you to do is maybe now go and put it into this URL k21academy.com forward slash which cloud, enter your first name and then your email address and select whether you want AWS or Azure or Google or Oracle Cloud. And then what I'm working behind the scene is I've already just finished a 12-day email series on or video series on AWS where we every day I'll be posting about or talking about one of the core services in cloud or AWS specific, which is about compute, storage, networking, databases, all those things. We'll be sharing that over the next 12 days or so if you picked up AWS. And like that, I'm preparing more for Azure, Google, and Oracle Cloud as well. So that's coming. So first, number two will be Azure, then it will be Oracle Cloud because I've worked extensively, and then Google Cloud finally. So go to k21academy.com/which cloud and so that you get some more additional free content and I need to also see how many of you are interested on which. We see a lot of guys opting for us also between thousands of guys. Majority still come to AWS and then followed by uh, Microsoft Azure for us. So I want to know which one you are interested in. Type here as well. Now, let's look at the comparison between AWS, Azure, Google, Oracle. What are some of the common services? And later part of this program, we're going to go deeper into these and learn some of these services. So from a compute point of view, compute is nothing but your virtual machine, which is your CPU and memory. In AWS, you have EC2, which is Elastic Compute Cloud. In Azure, they call it virtual machines. In Google Cloud, that's called as Compute Engine. And then Oracle, again, Compute Instance as well. Now, on the same thing, you also have a serverless version of compute, which means you don't manage the infrastructure, you don't manage about machines and anything like that. So you have serverless, which is a functions, which is AWS Lambda is an example from AWS. In Azure, you have function apps. In Google, Oracle, you have Google, you have a cloud function, and then Oracle Cloud again, you have functions. Now, containers we was talking about. So in AWS, you have ECS. I don't think it's AKS. I think I need to remove that EKS. It's ECS. Here again, you have as your container instances, or this is if you talk about Kubernetes containers, and if it's Kubernetes here. Containers, if you look at just containers, there is a container ECS, Elastic Container Service. This is you have Azure Container Instances. I'll fix this as well. And Google Cloud, again, Google Kubernetes Engine, and then Oracle Kubernetes Engine as well. Now, there's a Fargate, which is a serverless version of your ECS and EKS. I'll explain you on ECS and EKS in a minute. But uh, when you manage the underlying compute, which is your virtual machines on which your again, I'm going a little bit deeper, so I'll not go here right now. I'll just say that these are services available. Otherwise, I'll go in and explain some advanced things which you don't need to worry right now. Now, Kubernetes can be deployed in an like on-premise world, but implementation of Kubernetes we call managed Kubernetes on AWS, which is Elastic Kubernetes Service (EKS), on Azure, Azure Kubernetes Service, in Google Kubernetes Engine, and Oracle Kubernetes Engine. Okay, now S3. So sorry, you need storage, and there are three type of storage. You have a object storage, which is in AWS, that's S3, which means simple storage service. In Azure, you have blob. In Google, you have cloud storage, and Oracle, you have object storage. Then you have a block volumes or block storage where you need them for virtual machines or for your databases where data is written on a block by block. So that's a elastic block storage, EBS on AWS. On Azure, you have disk storage, and Google, you have persistent disk, and Oracle, you have block volume. Now, you also, from a storage point of view, you can have a shared NFS, network file share, or shared file system, which is a file system which is mounted across multiple machines and multiple machines writing to the same file system. So it's on AWS, that's an elastic file system. On Azure, Azure Files. On Google, you have File Store, and on Oracle, you have file storage service or file storage. Then you have a networking. Networking is your entire, you have, uh, um, think of it as a continuous block of IP addresses. You have subnets, network divided into subnets, and so on. So implementation of that on network on AWS is VPC, which is Virtual Private Cloud. On Azure, that's called as Virtual Network. Again, in Google Cloud, it's called as VPC, Virtual Private Cloud again. But in Oracle, they call VCN, Virtual Cloud Network. Now, you also need a DNS, a domain name service, which basically picks up a name and then convert it into IP address, point to IP address, which could be pointing to a load balancer or a machine or a VM or an IP, any IP address. In AWS, that's called as Route 53. In Azure, that's called as DNS zone. In Google, that's called as Cloud DNS, and Oracle, that's called as DNS. Now you also have load balancers. There are different type of load balancers. You have a network level load balancer and an application level load balancer. Again, as we go down deeper in respective module in programs, AWS Azure, we'll go and talk about those later. But from a high level, you have a elastic load balancer. These are application level load balancers. So you have elastic load balancers in AWS. In Azure, you have a load balancer normal. Uh, this is the naming convention they have. On Google Cloud, you have a cloud load balancing, and Oracle, you have load balancer. Then you have a connectivity tools for connectivity from on-premise to cloud, which is a dedicated, sorry, on-premise, yeah, on-premise to cloud. You have a dedicated pipe. You can connect using VPN, which is data moving over the internet. But then if you want a dedicated pipe, which means so you can control or you know how much data is moving, what is the speed bandwidth you get, which is a gigabytes and 10 gigabytes and 1 or 10 GBs data, which is a dedicated pipe. In AWS, that's direct connect. In Azure, that's express route. And then in Google Cloud, you have cloud interconnect. And Oracle, you have fast connect. Then you have identity and access management, which is your users, groups, roles, policies. In AWS terminology as IAM, identity access management. In Azure, you have Azure Active Directory, which is now rebranded as a directory services. You have, which is Azure Entra ID, but you also have, that's where you have all the users, roles, policies stored, and you can do federation, single sign-on, and so on. In Google, it's Google is Cloud Identity, and in Oracle, they have an Identity Cloud Service, which they are renaming and branding and changing it to Identity Domains. Inside that, you have your users, group policies, and so on. So Identity Cloud Service rebranded and renaming to Identity Domains. Now, from a security tools point of view, you have a Shield, which is a service in AWS. Corresponding to that, you have a Azure Security Center in Azure, Security Command Center in Google Cloud, and Cloud Guard is in Oracle. Now you have a web application firewall, WAF, which is a software-based firewall, which basically can see DDoS attacks or SQL injections and so on. So implementation of that in AWS is WAF, which is web application firewall. In Azure, you have an application gateway WAF. In Google Cloud, you have a Cloud Armor. Oracle again, web application firewall. Now, you want, from a security point of view, you want to encrypt the data at rest as well as in transit. So that encryption is done using key management service or KMS. In AWS, that's called as KMS, key management service. In Azure, that's Key Vault. In Google, that's Cloud KMS. And Oracle, that's Oracle Key Management OKM. Now you have a lot of data services or databases. You have a relational database services. In AWS, you have RDS, relational data services. RDS for Oracle, RDS for SQL, RDS for MySQL, RDS for Microsoft, RDS for and so on. They also have Aurora, which is a proprietary databases from on proprietary relational databases on AWS, which is Aurora. They also have Redshift, which is a online OLAP analytical databases or data warehouse solution on in AWS, which is Redshift. On Azure, they have Azure SQL databases, and they have also um, uh, analytics. Synapse is another one they have, but also Synapse they have a unstructured databases. We'll talk about that again. Um, or Cosmos DB and Synapse. There are a lot of changes that are happening on database sites on Microsoft Azure as well as in Microsoft Azure, which is we'll talk about in a minute. As we go in Microsoft Azure later, we'll go deeper into these databases. Now in Google Cloud, you have a Cloud SQL, and in Oracle they have autonomous databases, but with that they also have Exadata Cloud Service, Virtual Machine DB system, Bare Metal DB system, and so on. Then you have a for NoSQL, unstructured data, you have DynamoDB. In Azure, you have a Cosmos DB, but you also have Synapse, Azure Synapse. I think they're promoting more and more Synapse now. Google Cloud, they have Files, Firestore, and then on Oracle Cloud, you have NoSQL database. Now you also need ETL tools, which is extract, transform, and load. You have Glue in AWS, Azure Data Factory on Azure, Dataflow on Google Cloud, and Oracle Data Integrator Cloud Service, ODICS, Oracle Data Integrator Cloud Service on Oracle side as well. This is just a glimpse of just to know. You don't need to remember all of them. Just I'm telling you, you can compare them. And as you go later into these respective, as we go later in respective services, we're going to go deeper and we'll learn all these in detail later. Just an understanding point of view or just an overview point of view. So if you're preparing for interviews and if you hear these terminologies, they are not alien to you, or you can start at least make some context behind these services. Now, each cloud provider also provide now DevOps tools. So on AWS, you have code build, which is for code repository, code deploy for deploying the code, and then code pipeline, which is CI/CD pipeline you can build. Similar to that in Microsoft Azure, you have Azure DevOps whole platform. And if you're part of later part in Azure, we'll go deeper into Azure DevOps. That also has code repository, code deployment, code pipeline. All those things are in Azure DevOps. Similarly, in Google, you have Cloud Build, Cloud Deploy, and Oracle also have a DevOps pipeline, Oracle DevOps like in Azure you have. Now, in order for you to automate infrastructure build, you have infrastructure provisioning and configuration tool like Terraform and Ansible, but then each of these cloud provider comes with their own infrastructure provisioning tool. So like in AWS, you have CloudFormation. In Azure, you have Azure Resource Manager, but you also have Azure Biceps. In Google Cloud, you have a Cloud Deployment Manager, and in Oracle, you have Oracle Resource Manager. Now, for monitoring point of view, you have CloudWatch in AWS, Azure Monitor for monitoring in Azure, Cloud Monitoring in Google, and Oracle Cloud Monitoring in Oracle. And then for AI and machine learning, you have SageMaker, which is your machine learning algorithm, machine learning. You can run and build models. So you have SageMaker in AWS, machine learning service in Azure, AI platform on Google, and AI services on Oracle. And then there are other recognition, cognitive services, vision AI, or data science for data science tools like as well. So this is just in a high level about these services. This is a pictorial representation. Later we go into each of these. We'll learn. I think you have AWS for absolute beginners, Azure for absolute beginners, Google Cloud for absolute beginners, and Google Oracle Cloud. There we'll learn a little bit later on these, and then later we are going to go deeper into each of these services, much deeper as well. So that brings me to the next part, which is which cloud, or sorry, multi-cloud. So make sure you go and vote on your which cloud. But then back in between 2012, like late around, I think late 2011, I started learning cloud, and from 2012 and that cloud helped me a lot. But then in 2017, 18, I started realizing that hey, multi-cloud is the way to go, and that's where I think I would highly recommend you to, whether you're starting new or already working on cloud, multi-cloud is the way to go. And that changed my whole trajectory. Started getting contract as high as 900 pounds a day, 1,000 pounds a day, and so on. So that's what we're going to cover the next part, which is multi-cloud. Why? Who is using it? What exactly multi-cloud means? Though name suggests very straightforward, but I'm going to recap this full, and then why you should be learning multi-cloud and who is using multi-cloud, what some of the use cases, and later in later parts we're going to go deeper into these. Hey there, so this is Atul again. I hope you enjoyed the full course about cloud for absolute beginners. What I want to do is now continue this journey from here, and as I said in the class as well, go to this URL k21academy.com/which cloud, enter your name, email address, and select which cloud is right for you. Is it you want to go on AWS, Azure, Google, Oracle, or maybe like me, back in 2018-19, I transitioned to the multi-cloud. So if you want to go to the multi-cloud, maybe pick that appropriately. And based on your answers, we are going to take you with next journey, where we'll tell you a lot of other useful content related to that particular topic. And if you have, as I said at the start, if you have any questions, doubts, anything is not clear, or need some career guidance, do leave them as a comment, and we'll can't wait to help you. You'll be getting more useful content like that, and let us know what you liked, you didn't like, and so we can improve these videos. With that, to all your success and a result. This is Atul from Team K21 Academy. Thanks for watching this whole full course, and I'll see you in another video.